Stop tuning RAG by vibes. We will score retrieval with hit rate, MRR, and top K overlap, so you can prove your changes actually improved search. If you work with retrieval augmented generation, you have probably tuned tokenization, chunk size, or ranking, and felt unsure if you actually improved results. By the end, you will be able to run a small, repeatable comparison between two retrieval configurations and report clear metrics that guide decisions. I'm Professor Pi, teaching AI engineering and LLM systems with simple Python. RAG evaluation is a workflow problem. You want the right document in front of the model so answers are correct. People reach for lightweight retrieval tests when they need fast feedback before scaling to larger datasets or building expensive indexes. Success looks like measurable gains in retrieval recall or ranking that you can attribute to a single change, like unigram versus bigram tokenization. The intuitive idea is simple. Create a tiny labeled set where each query has a single correct document. Run two retrieval strategies on the same queries. Then compare recall, rank, and how often the two strategies agree. On a small corpus, you get fast, deterministic feedback you can iterate on. We will build a minimal pipeline that demonstrates this idea. It uses 3 short documents and 2 simple scorers. The goal is not production search, but clear, repeatable signal. Now we set up the tiny golden set. This snippet defines a tiny golden set for repeatable retrieval tests. We create 3 short docs in the dictionary docs, so they are easy to reference by ID. The list queries holds the evaluation prompts, while the dictionary gold maps each query to its expected relevant doc ID. Using compact strings keeps the width small and avoids external files, ensuring deterministic, self-contained behavior. The printed count confirms how many labeled examples you will evaluate against. The printed value verifies your ground truth size, an anchor for all later metrics. Next, we look at a simple unigram overlap retriever on one query. This snippet ranks one query under a simple token overlap retriever. The function toke lowercases and tokenizes text using Python's re to keep processing consistent. We select the first query queue and sort doc IDs by the size of the intersection between its tokens and each doc's tokens. The sort uses a tie break on the ID, so results are deterministic. This quick peek shows which doc config A, using unigrams, would pick first for the query. The printed top 1 result exposes how a unigram overlap behaves on your data. Now we expand that idea to top K and compute a basic hit rate. This snippet computes top K results and hit rate for config A. The variable K sets how many docs to keep per query, and SA measures unigrams overlap between a query and a doc. The list RA holds sorted top K doc IDs per query, with a deterministic tiebreak by ID. Hit rate counts how often the gold doc appears anywhere in the top K and averages across queries. Increasing K typically raises hit rate, but returns more candidates to re-rank later. The printed value shows config A's recall at K, a basic retrieval quality check. Next, we add a stricter scorer and compare rank sensitivity with MRR. This snippet adds a bigram-based config B and computes MRR for both. The function SB builds bigrams from tokens and scores overlap, making it stricter than unigrams. The list RB contains top K results for config B, sorted with the same deterministic tiebreak. The function RR returns the reciprocal rank of the gold item in a list, and the averages MA and MB are mean reciprocal ranks. MRR rewards placing the correct doc higher, so it is sensitive to order, not just presence. The printed pair compares ranking quality between configs in one glance. Now we measure agreement between the two configs and inspect a qualitative example. This snippet compares top K overlap and runs a quick qualitative check. The value O averages the fraction of shared results between config A and B for each query. High overlap suggests the configs agree. Low overlap indicates differing retrieval behavior worth investigating. For a light review loop, we pick one query and show each config's top one to inspect content differences. If overlap drops when you tweak tokenization or chunking, review what each top result contains and why. The printed line shows agreement level and a concrete example to audit. In a real project, this tiny test maps directly to a larger loop. Replace the 3 docs with your FAQ set or a few dozen labeled examples, and the same metrics will scale. The workflow stays the same. Small, fast checks first. Then, larger indexes when the signal is clear. Recap. It is a tiny labeled set plus 2 simple scorers, evaluated with hit rate, mean reciprocal rank, and top K overlap. Use this when you need fast, deterministic feedback on tokenization or scoring changes. One caveat: small datasets give quick signal, but can miss edge cases you only see at scale. Next step: tune one concrete parameter, like bigram threshold or K and top K, and watch how hit rate and MRR move together. That single change will teach you whether your tweak improves ranking or just shuffles candidates. If short, practical AI engineering helps, subscribe and watch the AI engineering videos.